getting started. Today we're gonna have, or I'm gonna do something a bit different. I'm gonna not do the open lesson thing today. Moment. Wait. We gotta stream first. Sorry, guys. Sorry. Let me just close a few things here, which bother. I need to actually producer, create broadcast, anatomy of an Eureka moment, and yeah, this is gonna be a good one. Okay, so the streaming actually I think is on. Let me just double check. That is all good, and we will actually post about these. Post these. I never know whether the stream actually starts from scratch or whether the first part of the streaming gets lost. Anyway, today, and I'm gonna actually switch to my local machine, so to the MacBook. There we go. Okay, cool. So that you see that. Because what I'm gonna be doing is these. Now, why do I see this frozen macOS capture? I don't. Why you can't see the screen? Give me a second. I'll add another macOS capture. Maybe that works better. The Retina display. Yes, sorry for the mess. All right, so the other one just seems to be broken. And I'm gonna put the camera feed on top. All right. So now we are, yeah, so you're seeing here. So what I'm gonna do is I'm going to and I'm just gonna put here because I want to make sure you're seeing these. All right, so I'm going to put this moment here. D is used. Whatever you use to create the public key is actually used here as the same factor that you're using to create. No, that's here. Yeah. D. Okay. What I'm trying to do is I'm trying to capture the 3 stages that I talked about. I'm trying to capture that first moment where it clicks. Then when I try to basically rebuild that and I can't remember the dream, you know, and then when it kind of finally settles. And so then if this equality holds, all right, so this is, yes, so what this is happening is because we're using D, and we only know D if we chose, like we're using the private key. Yeah, exactly. So because we're using the private key, not the public key to sign, but then D is also used in the public key. And the public key is known, so essentially we can do the calculation using Q, I see. There you go. Okay, here's when it clicked. So this I see. This is when it actually clicked. It's a pity that I was not wearing my headband. I'm gonna start wearing the headband again because I want to capture if anything changes in that moment in time. You know what I mean? Yeah. and the public key is known, so essentially we can do the calculation using Q, IC, IC.
Like that's the exact one. It's like it clicked.
I see. Okay, the beauty here is that we know these, we know DG, right? And I'm not going to go through the details of these. I can do that in.
And now I'm trying. The reason I'm doing these is that I'm actually trying to. So one of the things that I'm trying to do is, I'm trying to explain it. I'm trying to explain it, but it does not really actually come to my head, and I'm like, fuck, maybe I was too fast to to kind of call it an insight, like it almost feels like it shouldn't be like this.
Another session, probably that's worth it, but essentially, yes, now I understand. So it's because we're using because we know the public key, and the public key actually is computed using the private key, then there is an operation we can make on that signature that essentially guarantees that
yeah, I'm doubting here. You can see this, right? You can feel that I'm doubting you can feel that I'm doubting, and it's and that's that second stage. I'm kind of trying to re-explain this because I wanna basically reassure myself that indeed that was the right thing to click in my head,
that we use D. Hence, the private key. That's pretty nuts, actually. And it's quite cool if you think about these. You compute these two scalars, which is E and the inverse of S. This guy here. Then U2, which is R and the inverse of S.
I think I'm trying.
And you compute a point, which is basically using this linear combination of G, which is the known thing. It's the known point. And then Q, and then check if the x of this point equals R. So essentially, yes, you've put in here a Q which cancels.
And now, so we're 2:28 minutes in. Okay, so we're 2:28 minutes in. Yeah, let's open grok on the side. Okay, so we have. Hey Grok, can you pull up some research or whatever research most recent exists around an Eureka moment and the sort of the neuroscience or the brain activity related to the moment where we are getting an insight? I'd like to understand both from if there's anything in EEG space done that you can monitor on an EEG device, or fMRI, or not at all, or maybe there's something else that needs to be monitored.
With this D, right? And so you're making it cancel. You don't know what it is, but you're making it cancel. This is pretty nuts.
And this here it clicked hard, right? So it's like 2:30 at 2:28. I'm like, this is where I can explain it at a level that I'm happy to say, yeah, I understood that.
Okay, so I think I'm ready for these. So essentially, we know these because you can make a calculation. Let's remove these. So we know we can verify the transaction because there is a math you can run that essentially cancels out D and cancels out a component that is what exactly you're using to create the private key of so that public key. So you can prove it without knowing that number.
And here's probably finally what I'm just re-explaining it, and I'm like, yeah, okay, that's correct. So this is like this. I mean, it's funny. It's like it's probably about 2 minutes, 2.5 minutes that it takes to reconstruct a dream. You know what I mean? So what is interesting? What will be interesting here is to understand. Okay, so.
Yes, the neuroscience of Eureka, or aha, insight moments, has been actively studied, with both EEG and fMRI, and sometimes together or with other methods. These sudden insights, where a problem solution or new understanding pops into awareness after an impasse, aren't truly out of nowhere. Brain imaging reveals a cascade of preparatory processes, a burst at the moment of insight, and follow-on effects like enhanced memory encoding. Research uses tasks like compound remote associates, verbal puzzles, anagrams, chunk decomposition, or visual Mooney images, blurry black and white patterns that suddenly resolve into recognizable objects when restructured. Participants report the subjective suddenness, certainty, positive emotion right after solving, allowing trial-by-trial classification of insight versus analytical solutions. Foundational and EEG findings, timing and oscillations. Classic work by Mark Jung Beeman, John Cunhos, and colleagues, early 2000s, still highly cited, combined EEG and fMRI on verbal insight tasks. At the exact moment of insight, a sudden gamma band burst, 40 hertz, a prankton to 300 hertz, before button press response, occurs in the right anterior superior temporal gyrus, right temporal lobe area, involved in coarse semantic integration, connecting distant ideas, metaphors, or the gist. This is the neural signature of the pop into awareness. It is often preceded by alpha band increases, 8 to 12 hertz, over posterior visual areas, around 1 to 2 seconds earlier, interpreted as gating or inhibiting visual input to allow internal restructuring. More recent EEG studies, 2023 onward, refine the time course in other tasks. In a 2023 remote associates task, Insight Solutions showed pre-response power increases in alpha, left temporal peri D 2 seconds before, gamma left parieto-temporal, and theta fronto-central bands. Source localization pointed to left superior parietal, temporal, and frontal areas. In 2023 pattern recognition tasks, the Eureka effect involved right hemisphere alpha-theta coherence, increases, transient beta decreases, parieto-occipital linked to cognitive state switches, and other dynamic shifts. EEG is excellent for monitoring this in real time because of its millisecond temporal resolution. Research-grade EEG reliably captures these gamma, sulfa, theta signatures. Consumer EEG headsets, e.g. with good frontal temporal coverage and artifact rejection, can detect broader alpha-gamma patterns or precursors during insight-like tasks, though precise single-trial Eureka detection is noisier and less reliable than lab setups. Resting state EEG, even averaged over sessions, can also predict a person's tendency toward insight style versus analytical problem solving. fMRI findings, spatial localization, and recent advances. fMRI provides where in the brain these processes happen via blood flow changes, though with slower temporal resolution, seconds. Classic fMRI confirmed right temporal activation for verbal insights and showed distinct networks versus analytical solving, e.g., more default mode network involvement in insight. Very recent 2025-2026 work using visual Mooney image tasks has been particularly revealing. Becker et al., Nature Communications, May 2025. High insight solutions trigger representational change, restructuring in the ventral occipital cortex, VOTC, areas like inferior lateral occipital complex and posterior fusiform gyrus that handle visual object recognition. Pre to post solution. Multivoxel patterns shift from meaningless blobs to strong object representations. Simultaneous.
Really? Resting state brain activity as a predictor of cognitive style? A key discovery was the link between two brain rhythms, frontal and posterior alpha waves. Higher levels of alpha activity in the back of the brain are associated with analytical thinking, reduced spontaneous idea generation. In contrast, those... Okay. Since this brain area helps process broad concepts and distant associations. Super interesting.
These changes form a more integrated, efficient network and strongly predict better long-term memory for the insight memory advantage. Stronger subjective aha equals bigger effects. A February 2026 NYU study, he et al., Nature Communications, used fMRI plus EEG plus intracranial EEG on similar perceptual tasks and pinpointed the high-level visual cortex, HLVC, as the site where priors, stored past visual patterns, are accessed to enable one-shot perceptual learning and sudden recognition flashes. This helps explain how priors weight incoming sensory data for quick insights. A 2025 review by Becker and Cabeza frames insight as a prediction error process. An impasse creates a mismatch, negative PE. Sudden resolution updates internal models, positive PE, plus information gain, engaging hippocampus, medial prefrontal cortex, amygdala, and dopaminergic reward circuits, explaining the emotional rush and memory boost. fMRI is not portable, but gives precise spatial maps of these regions and network changes. Simultaneous EEG fMRI studies exist in other domains and could combine the strengths, though they're not yet the norm for insight research. Can it be monitored in everyday devices? Other methods? Yes, with EEG, as above, for temporal dynamics and oscillatory signatures, especially precursors or the gamma burst. Yes, with fMRI, for spatial localization and representational memory effects, lab clinical only. Not at all. These tools have been used successfully for quad 1 years, with accelerating recent progress, linking insight to memory, prediction, and perceptual priors. Other techniques, less common for real-time monitoring, diffusion tensor imaging, DTI, for white matter tracts supporting insight, intracranial EEG in clinical patients, e.g., hippocampal ripples preceding insight, or non-invasive brain stimulation to causally test regions. Bottom line, insight is the culmination of unconscious incubation plus sudden integration, visible as specific EEG bursts, oscillations, and fMRI activation, representational shifts in temporal visual hippocampal networks. The most recent work, 2025-2026, emphasizes how these moments don't just feel good, they literally rewire representations and supercharge memory encoding. If you'd like links to specific papers, task examples you could try yourself, or details on any study, just let me know.
So the sides are always hard. Again, you're not, like, again, it's frozen. You're not seeing my screen. Fuck, man. Give me a second. This is very stupid. Remove. No. Okay. So you're seeing that, and then, all right. I don't know if that's going to be the kind of let's see. T8. Bro, all I got is this. I got a Muse Athena S. I want to see what should spike. It averages the channels in here. Okay. 4 EG channels, TP9. So TP10 is green. TP10, your right ear sensor here. What is the gamma symbol? Is this guy? Yeah. All right, because it's actually, I think it's gonna soon collapse because of these. Okay, so the thing is, take 30-60 seconds, find one single word that can form a common compound word or familiar phrase with each of these three words. Find one single word that can form a common compound. No, that's not the kind of insight that no, we have to use this in an actual real session. I have to bring it back. I have to bring it back to open lesson. And I want to IES. So if I want to integrate the Muse in a Socratic tool, think aloud tool, what channels / aggregations are useful to see? I think that the aha moments, yeah. Because I could definitely put that on the, okay, it actually, fine. I need to charge this. I'll charge this up. And I need to, tomorrow we'll bring it back. We have to bring the Muse back to open lesson. Okay, it's end session. Mine 25%. Yeah, of course they make you pay for these, bro. All right. Okay, cool. I'll put that into the tool and let's see. I want to have a good. I want to have a good way to visualize these. Doesn't have to be with waves, actually. Anyway, see you guys tomorrow.